Now I'm going to use MATLAB to show you how to create an image using the color map and ImageSC function. In lecture I mentioned that there were two things that you needed to do when creating an image in MATLAB. The first is you needed to define a matrix of numbers that you wanted to plot. And the second thing was that you needed to define a color palette, or a list of colors that are possible to be viewed. Now, your monitor, as I showed in class, can support up to 24 million colors. And you can figure that out by looking at your monitor and right-clicking at Properties, Settings, and you can see actually this monitor only supports 2 to the 15th colors. And that's in part because we're using this through a remote connection machine. But most monitors that you have by default, if you're running the program from a laptop, standard laptop, you have 24-bit color, which means 2 to the 24 colors. That's a lot of colors. Let's start with something more simple, because typically when we want to look at matrices, we just want to highlight a few ranges of numbers. And so I'm going to start out with the most basic set of ranges, which is the numbers 0 and 1. And to represent those two numbers, I'm going to use black and white. So here is an editor window where I've defined C to be a matrix. This matrix has one row. This matrix has its first row with all zeros. Semicolon means start another row, and then a second row with all ones. Now this is the color map matrix, and just to remind you that these commas here are optional, but I put them in there just because in the future it's good habit to have them there. So if I type C on the command line, because I've already ran this and executed this program, I see that C is a matrix with 3 columns and 2 rows. And how you read this color map matrix is as follows. The first row is a color, and the second row represents a color. And the first column represents how much red, how much green, and how much blue. And so this means I want 0 red, 0 green, and 0% blue. And the second row means I want 100% red, 100% green, and 100% blue. So those are the two colors, obviously representing black and white. The next thing I need to do is define a matrix that I want to view, that I want to visualize as colors. And I've done that here, and I've already executed this program, so if I type in M, I see that my matrix that I'm going to plot has only 2 columns and 3 rows. And here's how I defined it, separated by a comma, and then a 1, 0, and then a 0, 1. So now what I'm going to do is execute these 3 commands. And this parentheses here means don't execute this last command. And so you can imagine you open up MATLAB and you punch in these commands, and this is what you should expect to see. I can type untitled, or equivalently I can press the play button. Untitled is the name of this file. Type that, and what happens is I get a matrix that is plotted. And obviously red and blue are not the 2 colors that I was interested in. And the reason I got those 2 colors is because MATLAB has a default color map. And that default color map is a default set of possible colors. It's a default color palette. And that default color palette you can find out by just typing color map, and what we'll see is 3 columns and many, many rows. And each row represents a possible color. So you can see the first color that's possible is 0, 0, 0 red, 0 green, and then 0.5625 blue. Pepper, I'm recording. And the last row says I want 0.5 red, 0 blue, 0 green. And so, as you probably guessed, the 2 extreme colors are actually the ones plotted. We'll come back to that statement later. Now I want a more simple color map just so I can figure out what's going on. And here I've typed in C, a matrix C with 3 columns and 2 rows. So in other words, 2 rows, so I want 2 possible colors here. But MATLAB doesn't know that I want that to be the color map, and it just uses its default color palette. So to instruct MATLAB that I want to use that color palette, I have to pass this capital C matrix to color map. So now let me run untitled, typing untitled, and what you see is that I have now plotted that matrix M using that color palette. And let's see if this makes sense. 0 and 1, 0, 1, 1, 0, and then the last row is 0, 1. So what it appears is that MATLAB has rendered this matrix with this 0 corresponding to this tile, this 1 corresponding to this tile, this 1 corresponding to this tile, and so on. And it has used those 2 colors. Now, what do you think will happen when I change the color map? So let's go to 3 colors, 0.5, 0.5, 0.5, semicolon, 1, 1, 1. I have 3 possible colors, but I only have 2 numbers in my matrix that I'm going to plot. And the reason I'm doing this is that so we can investigate how MATLAB decides what to show you. I will type untitled, and what I will see is that nothing has changed. Even though I have 3 possible colors, because I only have 2 possible numbers, only 2 colors are plotted, only the extremes. And so it would appear that the 0 corresponds to the one extreme, and the 1 corresponds to the other extreme. So now suppose I take this matrix, and instead of having just zeros and ones, I have a 0.5. What's going to happen? I will run untitled, and now you'll see one of the values is gray. And we can verify how MATLAB is defining colors by asking it to plot a color bar by typing in the command color bar. And what we see here is that the choice that's been made is that any number between 0.68 or so to 1 is rendered as white. Any number between 0.3, 0.68 is rendered as gray, and 0 to 0.32 as black. So let's see if I change this to 0.7, what will happen? I would expect that now 0.7 is, in this tile, is going to be rendered as white. Indeed it is, and so now all of those values on the right hand side are white. And if I change this down to 0.3, I would expect that that becomes black. So now you can see how the basic color map works. It's essentially, color bar, is that you give MATLAB a series of numbers and a total number of colors that it could represent. And then MATLAB makes a choice as to what color to associate with each number range. So what's happened here is that the numbers in my matrix M vary from 0 to 1, and I've given it 3 colors, and so it looks like it's divided the range of 0 to 1 into 3 chunks, and with each chunk corresponding to a color. So now instead of looking at matrix M being just 2 columns and 3 rows, I want to look at a matrix that is a set of random numbers, and it's going to be 100 random numbers by 100 random numbers in the matrix. Now, we'll clear, and I will run untitled. And what you see is a grid of black and white tiles that are very, very small. If you zoom in here, you'll see that each point is represented by a tile. I guess I can zoom in here by clicking on this bar, and you can see that each tile is of size 1. It's a square of size 1. I'll clear the screen and run it again to go back to the default zoom, and see here you can see the axis goes from 0 to 100 to 0 to 100. But now if I look at M, it has lots of numbers. So M is a 100 by 100 matrix. These are just a few of the numbers in it, and they vary between 0 and 1. So obviously this color map isn't useful as a good representation of these numbers, because these numbers vary on a very, very fine scale, but the color map does not. So we can modify that. We can add more colors. 0, 0.3, 0.3, 0.3, semicolon, 0.7, 0.7, 0.7. Save, and I will run. And now you can see I have gray and black. And if I do color map or color bar, you can see that it's divided the range from 0 to 1 into 4 pieces. Now we can think about using the default color map. So instead of using C as the color map, I'm going to comment this out and comment this out, which essentially means anytime you have a percentage sign in front of a statement, so if I do A is equal to 1, nothing will happen. If I do A is equal to 1, the value of A will be assigned to the number 1. So a comment means just ignore everything that follows. So this will not be an error because there was a percentage sign there. And comments are useful in programs because you can say, you can comment on things. You can say, for example, the following creates a 10 by 10 matrix with random values in the range 0 to 1. And every programming language has the capability of doing comments. The only difference is that some languages want to use the hash or the pound sign. Other languages use this to indicate a comment, and others use this. MATLAB just likes the percentage sign. What I am going to do next is to, instead of using my own color map, here where I had 4 rows and 3 columns, RGB columns, I'm going to define a color map using this special function called jet. And this jet8 means return 8 colors. So let's try it. At the command line, jet4, I expect to get 4 rows. And sure enough, I get 4 rows. If I do jet8, I get 8 rows. And so it has 8 possible RGB colors. And here I've done jet8. So now when I run this, untitled, it creates an image, and then if I zoomed in, what I expect to see is 8 different possible colors. Let me run this again, and then let me add the color bar. And what I see is 1, 2, 3, 4, 5, 6, 7, 8 different colors, and the range is from 0 to 1. Now,